Yeah, viewers, welcome to Young Maths Academy. We'll continue our lecture on bearing and distances. This is lecture 4 on bearing and distances. You can see on the board, the question says an aircraft takes off from an airstrip at an average speed of 20 km per hour on a bearing of 052 degree for 3 hours. It then changes course and flies on a bearing of 028 degree at an average speed 30 km per hour for another 1.5 hours. Find the A part of the question says its distance from the starting point. B, the bearing of the aircraft from the airstrip. So here we are going to treat this question, bring out a triangle, find the distance and obtain the bearing. I will have to rub off the board to get a proper diagram for this question. Okay. So what I will do, I will create my 4 cardinal points, my airstrip, north, south, east, west. Let point X be the point of the airstrip. Airstrip is the ground level where an aircraft takes off from. So the aircraft took off from the airstrip at a bearing of 052. So I'll create a small arc. I'll draw this line this way. This is 052 degrees. And it was stated that it traveled on a speed of 20 km per hour, and it took 3 hours for that journey. We obtain our distance. Remember, under motion, the speed is distance per time. So our distance here is 20 by 3. Distance is 60 kilometers. So the distance it took is 60 kilometers. Here, let me just quickly rub up this. I'll create another 4 cardinal points, north, south, east, and west. Then the question says that it then changes course and flies on the bearing of 028 degree. So here, this is this way. So like this. Very good. So at this point, it changes course and flies on a bearing of 028. I'll create a small arc this way. Then I draw a line just like this. I'll create another 4 cardinal points, north, south, east, and west at this point. So that we have this, yes. Now it travels for 1.5 hours at a speed of 30 km per hour. The speed is 30 km per hour. The distance, the time it took is 1.5 hours. So our speed is our 30 by 3/2. 1.5 is 3/2. So this gives us 45 kilometers. So the distance it took here is 45 kilometers. And we just have to write this 60 kilometer here. Here is 60 kilometer. 60 kilometer. So I will join this. I will trace this and join this way. So we have a proper diagram. So this will form out a triangle for us. Create a triangle if properly drawn. So from here, this is point X. We know this label is Y and label is Z. So that's opposite of Y, the side length will be Y kilometer. The X here, this is our X kilometer, and this will be Z in kilometer, the side length. So before we'll be able to obtain the distance, this distance covered, this is the point where the aircraft is now, the position of the aircraft now. To get this distance, we need to obtain an angle in the triangle. So we already know that from this north to this line here is 0.52 degree by rule of alternate angles, just as we've said before in previous lecture. If you have two parallel lines and a transversal line going through them, passing through them, if the angle here is theta, then the angle here should be theta as well. Alternate angles are equal. That's facts on parallel lines. So here will be 52 degrees as well. And we are told that it's moved on a bearing of 0 to 8, 28 degrees here. And we likewise know that from this point to this point is a 90 degrees. This portion can be obtained by saying if from here each of the quadrants is 90, here is 90 minus 52 degrees, that gives me 38 degrees. So here is 38 degrees. So I can say 38 by 90 by 28, that gives me 156. So I have the total angle here to be 156 degrees. Now it implies y, the angle y is 156 degrees. Our cosine rule states that to get our y squared is equal to x squared plus z squared minus 2xz cosine y. So your y squared is equal to, our x is 45 squared plus 60 squared minus 2 by 45, 60 cosine 156 degrees. So that our y squared is 45 squared, we check that with our calculator, 45 by 45, we have 2025 plus our 60 squared will give us 3600. Then we punch this in our calculator, we have minus 2 by 45 by 60 by cos 156. We have the value to be positive 4933.145. So that here we have y squared is, so we just sum up these values, 2025 plus 3600 plus 4933.145, and here we have 558.145. So we take the square root of both sides to have the square root of our answer gives us 102.75, and we have that to be y equal to 103 kilometer. So the distance covered is 103 kilometer. We've been able to get the distance. Now we obtain the bearing according to question B. So to get the bearing, we just rub off this and I take that as well. So to obtain our bearing, since the triangle is not a right angle triangle, we make use of our sine rule. And it states that sine of a capital X over small x sine y, or this angle over small y, and sine z over small z. X is same thing as theta. We want to find this angle here, theta. So sine theta over small x is equal to sine y over small y. So that sine theta over x, so the opposite is 45, the side length there is 45, sine y. So sine of 156 sine 156 over our y here is gotten to be, we obtained that to be 103. So 103. So I will have to rub up this diagram here. Here sine theta becomes sine theta is equal to 45 sine 156 degree over 103. So we punch this in our calculator. 45 sine 156 divided by 103, that gives us 0.17. So we have that sine theta is 0.17770. So we take arc sine on both sides. So we have sine inverse 0.17770. So theta is the arc sine of that value, 0.17770. So we have 10.2358. So 10.2358 degrees. But to two significant figures, we see this is 10 degrees. Yes, this is not the bearing, this is just the theta, the angle we obtained at that portion in the triangle. Don't forget, in that diagram, I will have to draw the diagram again so you can properly see what to do next to get the bearing. I'll just assume that, quickly draw a rough sketch, north, south, east, west. We add this to be 052. It went, like this. We have something just this way, north, south, east, west at this portion. So we created another arc and we went something like this, another north, south, east, west. Then we had something like this, So just this way. So at this point was 052. Here we have 028. Here is a 90. Here is 38. Everything sums to 156 degree. Here we have 60 kilometer. So here 45 kilometer. We have 103 kilometer. So that now we want to get the bearing. You will notice from this line, North Pole to this line here, we have it to be the 05 to the bearing, 05 to the root. So theta already lies in this angle from here to here. So, and we are interested in the bearing of where the aircraft is now. You can see this line. Bearing is an angular movement between two distant places to this point. So we are interested in this bearing. So just this portion in this bearing. So, and how do we do that? We have to subtract theta from 052. So we say 052 minus theta. So that we say bearing is 052 degree minus theta, 052 degree minus 10 degree, which gives us 42 degrees. So we've been able to answer the question successfully. Thank you.